All right, hello and welcome to week 2. Let us get started. So, where we left off last time was we talked about the beautiful types of char and string. And now we're ready to talk about types in general. So, we only have a finite amount of memory in our computers, and so we need to figure out how much stuff each type lets us put in it. Because some things are different than others, like doubles can't hold decimal places. Why not? Well, let's find out. All right, so this is a table that I'm going to show you again later after I've taught you more about what all these terms mean. Okay, so just the size of a type, it just means how much information it can hold, what can go inside of it. Okay, so for an int, for example, it holds 4 bytes, which is 32 bits, and I'm going to explain what all these things mean. And with that much space, this is a unit of space, we are allowed to represent this many numbers. We can represent every integer from -2 to the 31 to 2 to the 31 minus 1. Whereas char is fewer bytes, and it can represent things, well, if you convert them to numbers, that is, it can represent much smaller ranges of numbers. Doubles have twice double the amount as an int, and, well, they can store a lot of things, but they store those things in a different way, and that allows you to hold decimal places, and you get about 16 digits of precision in a double variable. There's also a float, and that's 4, and because double is double the float amount, that's why we call it that. Short and long, long, that is, those are also integer types. Double and float are the only floating point types that can hold decimal places. Short and long can hold different amounts. If you want to hold a ton of integers, maybe you need a long instead of an int. Okay? But these are all weird terms, all of these things. Maybe you haven't heard of them before. So let's figure out what a byte is. Let's learn all these things. All right, so I'm going to teach you first this thing called base conversion, because that will explain these concepts a bit better. They will be more ingrained in your mind after we do this. Okay, so let's talk about bases first. So the numbers that we know and love, those are written using what we call base 10, okay? And that is because we have 9 digits to choose from to build those numbers with. These are the ones that we have. We start counting 0, 1, 2, 3, all the way down to 9, and the second we get past 9, we have to add another decimal place because there's not enough room anymore. Okay, and the reason people think we have base 10, and we decided on that, is because we have 10 fingers. And so if you're in the Simpsons world, maybe they used base 8. All right, now binary is base 2, so very similar to base 10. You have 2 digits to choose from, and the 2 digits that we have in binary are 0 and 1. Well, that means once you start counting 0, 1, you're now out of space and you have to add another place. So 1, 0 is 2 in binary. Isn't that cool? And because I'm going to write a bunch of different numbers, I am going to subscript them. So if I say 1, 2, 3, this is, or how about I do this? If I say 1001, I can write a 1, 0 down here to mean decimal. The decimal 1001. But if I write 1001 base 2, that means I'm talking about a binary number. And these are 2 separate numbers. Okay? So that is binary in a nutshell. A binary number is just a number that's written in base 2. And each digit in a binary number is called a bit. Okay? That's all it means. They just shortened it. They took a B and then the IT here, and then they just got rid of those letters in between, and they call it a bit. So this is a 4-bit number. 4-bit binary number. And if you have enough of them, you get a byte. So 10110110, that is a 1 byte. And it's understood that it's written in binary. Okay? So because 1 byte is 8 bits, these are all the numbers that you can have in between them. You can go from 0000 all the way down to 11111111, and we'll soon learn what those all mean. Okay? So that is binary. Let us learn how to convert between these different bases now, okay? And just as an aside, like if I was giving you a base 5 number, well, then you have only the digits 0, 1, 2, 3, and 4, okay? And then 5 would be 1, 0. That's the idea. Okay, so let's convert from binary to decimal now. And the way it works is to use power expansion, and this is essentially something that you've already learned in like elementary school. Remember how you were taught to break down 1, 2, 3, 4? That binary number 1,234? You were taught to do something like this. Well, it's 1,000 plus 200 plus 30 plus 4, right? That makes the number. And once you got a bit older, maybe they started telling you, okay, that's 1 times 1,000 plus 2 times 100 plus 3 times 10 plus 4 times 1. And maybe once you got even older, they started saying, oh, okay, yeah, this is 1 times 10 to the 3 plus 2 times 10 squared plus 3 times 10 to the 1 plus 4 times 10 to the 0, which is just 1. Okay, so with this in mind, I hope you see the pattern. Because we're trying to break down a decimal number, look at where the base appears. Boop, 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 and boop. So if I were to do this for binary, if I wanted to convert from binary to decimal, I'm going to do the exact same thing with this number, but swap out these 10s with 2s. All right, so over here, I've got the 0. I'm going to start from right to left, all right, right to left. I got the 0 times 2 to the 0 plus this 1 times 2 to the 1 plus 0 times 2 to the 2 plus 0 times 2 to the 3. And then finally, oops, I already gave the plus 1 times 2 to the 4. And this tells us what this number represented in binary. What decimal number was this? It was 2, 4, 8, 16 plus 2, 18, base 10. You see that? So maybe give this one a try yourself, just to prove that you understand this process, and we'll go from there. So assuming you give it a shot, well, it's 1 times 2 to the 0 plus 1 times 2 to the 1 plus 1 times 2 to the 2 plus 1 times 2 to the 3. Okay, so that is 8 plus 4 plus 2 plus 1, which is 15, base 10. Okay, fun stuff. And now you're experts. Now you can go from a binary number to a decimal number very simply. Okay, you just do this process. All right, maybe you want to go the other way now. Okay, and this is not something I'm going to test you too hard on. If anything, it'll be like a multiple choice question on your exam. There's always websites that convert it for you, but it's good to know how. Okay, it's good to know how to go the other way. If I have a decimal number, how do I make what the number is in binary? Okay, and to get us there, to teach you that, I'm going to first tell you how to extract all the digits of a decimal number, because we're going to come up with an algorithm, a sequence of steps to break down any number, any decimal number to any base. So let's find patterns in decimal land first. Okay, so how would we extract the digits from the decimal number 1, 2, 3, 4, base 10? And if you think about this long enough, there is a way, and you can program it, to get the 4. Okay, how would I get the 4 out of this 1, 2, 3, 4? How would I know if I stored the variable 1, 2, 3, I stored in x this number? How would I get the 4 out? Okay, I'd be doing x something. And now it's time for me to teach you a new operation. Okay, so in C++ you have slash for division, and there's this percent sign as well. This is called modulus, or modulo. It's the modulo operator, and it gives you the remainder. All right, so let me prove that it works to you, and this is going to be very useful. Okay, so we're in CSCI 40. I need to make a new folder for lecture 3. Say make dir lec03 to make that folder. There it is. Let's go on inside lec03, not lab03. Now it's empty, and let me make a new file called mod.c++.cpp. All right. And int main, then return 0. How about we ask the user for a number, call it x, get that number, and then output that number, I don't know, mod 2. X space mod 2 equals, or %2, we can say, equals, then we give it x mod 2. All right, so this % is the modulo operator. It gives you the remainder. So x mod 2 is the remainder of dividing x by 2. Okay, so essentially x mod 2 is going to tell you if it was odd or even, because it'll be 1 or 0. All right, and now let's go and compile this. G++ standard equals C++ 17 mod.cpp-o mod /mod, and let's enter, I don't know, 42. Ooh, 42 mod 2, yeah, that's 0 because it goes in cleanly. 2 goes in without a remainder. 41, however, it's going to be 1 at the very end because this is an odd number. It doesn't go in cleanly when you divide by 2. Okay, so that's the modulus operator. And it just so happens, if you think about this hard enough, you can mod 1, 2, 3, 4 by 10 because when you divide it integer division, or just anything, I guess, 1, 2, 3, 4 divided by 10 is 123 remainder 4. You see that? That's how we can extract the 4. Isn't that cute? And then we can compute this process again and again and get the 3, the 2, and the 1. We just have to turn 1, 2, 3, 4 somehow into 1, 2, 3. So that we can do the process again of getting the rightmost digit. So how do we turn 1, 2, 3, 4 into 3? Think back to your integer operations. Well, if you do integer division, oh man, that gives me just 1, 2, 3. Isn't that also cute? So that together, those two operations, integer division and modulo, together give you an algorithm to extract the digits of any number. 1, 2, 3, because this is integer division. Oop. Int div. Maybe I should put this in a different spot. Over here. Int div. All right. So then I have 1, 2, 3. I can extract the 3 by doing the mod 10 again, because the remainder when divided by 3 is 12. Or it's 12 remainder 3, right? When you divide by 10, 123. So there's my 3. And I can do it again. Now let's get 12 back so I can get the 2 out of 12. Equals 1, 2. 1, 2 mod 10 equals 2. 1, 2 integer divide by 10 equals 1. 1, 2 mod. No, sorry, just 2. No, my bad. Just 1. These numbers are hard to keep straight in my mind and hard to write and talk. 1 mod 10 equals just 1. The entire thing is the remainder, goes in 0 times. And then finally, 1 integer divide by 10 is 0, and that's how we know we're done. Okay, and so you can kind of read it backwards. You just, every time you took the modulo, you extracted a digit. 1, 2, 3, 4. And it's this algorithm that actually works for any base, because just like over here, where we noticed a pattern, there's another pattern in this one. Oh, let me choose a color, please. Choose rainbow. So notice what we're taking the mod and the integer division by. Oh man, is it our base that we want to convert to? So this actually works for any base. You start with a decimal number and you repeatedly divide, and then you take the modulus in the same pattern. But if you do it by the base you're converting to, you end up with a number in that base. Isn't that interesting? So let me convert 15 base 10. Well, what is that in binary? Okay, we know because we gave ourselves an example of that. But if you didn't know, you could use this process. You could say, all right, start with 15. I'm going to mod it by the base I'm trying to convert to, 2. And that will give me the rightmost digit of whatever this is in binary. Okay, so it's an odd number, so I get back 1. And then I'll do the same thing. 15 integer divide by 2 equals 7. Then 7. Use that now to get the rightmost digit in binary, because there are multiple digits for every decimal digit. Okay, it's a little weird, but it does work. So 7 mod 2 now. Again, it's odd, and we expected that because it's supposed to be 1, 1, 1, 1, right? And 7 integer divide by 2, that's 3.5. Drop the decimal places, it's 3. 3 mod 2, what do you know? It's 1. 3 integer divide by 2 goes in 1 time cleanly, and then 1 mod 2, lo and behold, is 1. 1 integer divide by 2 is 0, and that's when we stop. And then again, every time we took the mod, but it's by a different base this time, it's the one we're trying to convert to, we got a digit. We got 1, 1, 1, 1, and that is our answer. So it equals, well, it's 1, 1, 1, 1, base 2 is our answer. That's the idea. Okay, so that's how you can do it. And you can double check yourself, of course, always, because you can go from this to something in base 10 always, because you know how to convert that. That's the easier way. You just do the expansion, and you can check yourself. So this is 15 because it's 8 plus 4 plus 2 plus 1. All right, so that was fun. Back to programming stuff. And I hope now this table makes a bit more sense. And the reason, like, now you know exactly why these are the numbers you can get. Well, almost you know exactly why. The way that we store negatives is a little odd, but it will make sense once you learn that too. But imagine you have 4 bytes in an int, that's 32 bits. You have 32 possible 1s or 0s. And you can think of just how big of a number you might make. It's around this size, okay? And now you know why 1 byte is a certain amount, and so on and so forth. Okay, and I encourage you to read up on this in your book too, because it's very useful. Okay. Now, back to real programming. There may come a time when you want to store something that you never want to change ever again, okay? Because you know right now with like your int variables and things like that, if you set it, you can actually change it. You can say x++, and now suddenly, like, x, which was 42, is now 43, and you can just reset it again, like, okay, now it's 47. You can play this game all day long with x, and poor x. You never know who he really is. This is different when you use const. When you put const before the name of a type, it means that the variable you're defining of that particular type cannot be changed. Okay, constants cannot be changed. So this const right here means that double pi can never be changed ever again. Okay, you cannot set it equal to something else. And let me show you that. And it will actually be a compile time error to even try. Okay, so let's do const.cpp. So let me make, I don't know, const double pi equals 3.1415926535, and then, I don't know, const int 40, no, x equals 42, and so now I have 2 constants, and maybe I want to, like, try to do this, like x equals pi times 5 or something. It's okay to use a constant, but it's not okay to reset a constant. This will be a compile time error, okay? So let me just try and compile it. And it's going to be like, oh, no, sorry, assignment of read-only variable x. So you're trying to rewrite to x some new value, and that is not okay, my dude. That's const. It might come in handy one day. It makes it easier to think about your programs because you know what can and cannot be changed at a bit finer of a level. So that's fun. And now we get to some extra cool stuff, because we get to talk about function calls. So in the libraries that are written by people other than us for us to use and take advantage of, people have written a ton of these things called functions. And a function just performs some operation that's predefined, and we can use it as many times as we want. So formally, a function is a piece of code that you can call multiple times. When you use the function, we call it calling the function. Okay? And so let me give you an example. In the math library, we have the square root function. It's named like this. And we can call it with 2 to get back the square root of 2. Okay? And then we can use this in a larger expression or like print it out or something. It's quite nice. And so stuff that goes in between these parentheses are called arguments. So functions can take optionally as many arguments as they want. They don't have to have any even. Okay? There's one function called rand, which we'll talk about, which takes no arguments and returns back a random number, which gives us back like, I don't know. This gives us back like 1.41 whatever, and this gives us back, we have no clue. We can try it as many times and we'll get a different number too. Maybe this is like 1048 or something. I don't know. Random gives us a random number. That's the idea. So yeah, these functions can take as many arguments as we want to give them. Sometimes they have a set number like square root and like rand, and those arguments control the way the function works, the way it does its thing. Okay? So a lot of the time, these functions give back an answer. Like square root of 2 gives back this decimal value that is the square root of 2. Random gives back an integer that's a random number. And I'll give plenty of examples of these, don't worry. The idea is you get to pretend that your function call will be replaced with that answer. Okay, so if you say, I don't know, let me teach you the power function, like, I don't know, double y equals pow, stands for power, 2.5 to the 1.5 or something. This will set y to be this result. You get to pretend that the function call gets replaced with the real answer, which is, in our case, 2.5 to the 1.5, whatever that is. Okay, so these are all my little examples, and they're all quite nice. Okay, so this is called a function call. Okay. It's super wonderful. And each argument, just so that I don't forget later, each argument, in addition to being required, sometimes it has a required type. So maybe argument 1 has to be type 1, like an int. Argument 2 has to be type 2, like a double or something. We'll notice this later. But this is a good introduction, I think, and now let's get some examples under our belt. So we're going to explore some libraries. We have been talking about IOStream. We've used that for cout and cin. There are more. Okay, and the places that I want to show you where to learn about them are all the documentation pages on this c++.com website. Okay, so here we are, and you can pick any of these files. They're called header files, and read more about them. Okay, so let me search for IOStream. C library. Dun dun dun. I don't see it, but I know it's here. Input output IOStream. At least it's there. So here it tells you about cin, cout, things like that. Super nice. It's like, okay, here's what it does. Here's how you can use it. And they also have some examples a lot of the time. If you just keep on clicking. It's like, okay, what does the 2 arrows mean on cout? Things like that. Okay, fun little examples, and this is a very useful website. All right, the first thing I want to show you is, let's see here. Let's go to cstudlib. It's from the C library, so they put a C at the front of it. cstudlib stands for C Standard Library. Okay, so I guess we're going in this order first. I'll swap these. Dun dun dun. cstudlib has some fun stuff. It has rand. We'll talk about that soon. But a nice one for integers, it has all these little functions like abs. Abs gives us the absolute value of a number. So it takes an integer, one integer, and gives us back an integer. That's how you can read these things. Okay? And it gives us a nice little example, and we can do it ourselves. Okay? So let's do math stuff over here. I'll call it mathstuff.cpp. And here we go. So let's see here. I need to include the header for the things that I'm going to use in the library. So I'm going to include cstd_lib because I want to use for abs. So for example, we can ask the user for an integer, make room for it. Hey, user, enter 1. Get it. And then we can output the absolute value of it. Cout abs of x. That's how you read it. So this is going to get replaced with the absolute value of x. Okay, I hope that makes sense. This is a function call. It's very useful because somebody else has written this nice absolute value function for us to use. Oops, gotta call it something different. There we go, enter number 42. Absolute value is of course 42, but if it were negative, hey, it makes it positive now. That's useful, that's good to have. Okay, so that is absolute value. Gosh, there are so many. There are so many, it's wonderful. Let's explore CMath now, just to give you a taste of everything. CMath, it's in alphabetical order. You have all these nice functions. Sine, cosine, tangent, which return to you doubles. It's like, okay, what's the cosine of, I don't know, pi? Things like that. Super fun, and they all make sense. Some ones that maybe I can show you is exp. Like this gives you e to the power of something. So exp of 5 gives you e to the power of 5. You can read more about it here. Examples and things. Maybe we can output. We need to include CMath, of course. We're about to use it for exp. Let's output exp of x. So what is e to the negative 42? Let's find out. It's going to be some small number, of course, but that's just how small it is. And this e means times 10 to the. It's a very small number. So, all right, how about to the 42? Now it's a giant number. Okay, very fun. And if you just want to e itself, you can give e to the 1. Isn't that nice? That's e to the power of something. Yeah, so like exp of 1 gives us back e to the 1, which is just e. What are some more? Let's explore. Click my little back arrow. Here's the power function, the square root function, which I think you can understand. It gives you the square root of some number. It could be a double. So let's enter another number, double y. Let's say c and y. It's going to give us a double value now. All right, and then we'll see out the square root of that number that we were given. Isn't that fun? So now we're using it for square root too. So I don't know, 42, and then I don't know, 2.5. Square root of 2.5 is apparently this. Not too bad. All right, so all these nice little functions that we can use for our own selfish purposes. It's wonderful. Two other things that you might one day care about is ceil and floor. Ceiling and floor, they take doubles, they give you back a double, takes a double, gives you back a double, and ceiling gives you the next highest number, rounds it up always, and floor, it's the opposite, it's on the ground now, it always rounds downward, so it just chops off decimal places. So this is kind of like converting to an int, and this is kind of like rounding up always, even when it's 3.1, it'll make you 4. So, for example, if you had 2.15, the ceiling of that would give you back 3, and the floor of that would give you back 2. Okay, so those are those two. Might come in handy one day. And one that I do want to show you that will be helpful is called round. Okay, and round does the normal rounding. All right, so here it is. Boop, boop. Where is our round function? Oh, I'm just going to search for it. There it is. So close. So round just rounds to the nearest whole number, as you know in math. It takes a double, gives you back a double. And so if we were to say like round of 2.5, it would give us back 3, but round of, I don't know, 2.15 again would be just 2. Okay, that's the normal rounding that we know and love. So I will output that as well. Now we're using it for round 2, recompile, rerun. And so yeah, rounds up to 3, or 2.15 rounds down to 2. Okay, so that's math functions, very cool things. Next, let's just keep on trucking. I want to talk about random numbers, because those are very useful, and those let us do different things each time our program runs. We don't even have to ask the user for something. Okay, we're going to get random numbers. It's going to be very cool. All right, so rand, it's a function that takes no parameters. And when you call it, it gives you back a number between 0, ... all the way down to rand max, which is a very large number. Okay? And so what rand does is each time you call it, it gives you another random value in the sequence. So maybe the first time you give it, you ask it for a random number, it gives you 1, then it gives you like 42, then 85, then, I don't know, 12, etc. It's always a different value each time. That's quite different to something like square root, which is always going to give you the same value back for the same number. Okay, so it's randomness. It's quite odd. So yeah, let me give you some demos, and then I'll talk about this large wall of text. All right, so for my first demo, let me output 3 random characters. Okay, here we go, here we go. Rand.cpp. And so rand exists in the c_stdlib library. There it is. And what we're going to do is replace all of this with calls to rand. So the first thing that we're going to do is output 3 random characters. Let's make that a comment so we know our game plan. So we have to come up with 3 random characters. Let's use this. Let's do it. Char c1 equals, I don't know, well, it's going to be rand. And do you remember what these values can be between? Well, 1 char can be between -128 and 127. So, darn. We can't really get back negative values from rand. You can, but it's a bit difficult. But 127 is a bit small compared to rand max. So right now it's not good enough, because if I call it just rand, like, I can't really convert that to a char very easily, because I need a very small number for every char. And let me show you the kinds of large numbers that rand gives us back. See, that's not fitting in a char anytime soon. So we need to make it smaller somehow. And I want you to stare at the following beautiful concept. If you use the modulus operator, the modulo operator, with some number, it's always going to give you back a number between 0 and num -1. That is beautiful. And the reasoning for that is, okay, let's pretend we got a random number back. It was 42 or something. If we did mod 3, or let me make a smaller number so that I can actually do this division in my head. I don't know. Let's make it 7, mod 3. the idea is no matter what number you put over here, it's only ever going to be 0, 1, or 2 because, all right, you got 7 mod 3 is 1, 8 mod 3 is 6, 2, and then 9 mod 3 suddenly goes in full and you get back 0, and this just keeps on repeating. Okay, so if you take a random number and you modulo it by some number, you're always going to get back a number between 0 and that number minus 1. That is useful for us. And also, well, we'll deal with this in a second. All right, that's quite useful. So now, dun dun dun, are you ready? Let's make a first character. And remember that our characters can go between negative 128 and positive 128, but let's just keep it positive. So let's come back with a character between 0 and 128. Okay, so I'm going to follow this table, just keep the positive ones. Oh, sorry, 127. So what does that mean we need to mod our random number by to get back something between 0 and 127? Well, it's that number plus 1. We're going to mod by 128. That's probably why I kept saying it. C1 equals rand mod 128. This gives us back a number between 0 and 127. Okay, so it's not including 128. And so we can do this 3 times to get back 3 random characters. Boop, boop, and boop. And we can output them. Output C1. We don't need to end the line. Let's just output them right next to each other. C2, then C3, and then a new line. And I think that'll work. So we got back G, capital F, and lowercase I. Isn't that cool? Okay. Another cool thing is we can get a random number between 1 and the user's choice. So if when modding by something gives you back a number between 0 and that number minus 1, how can we go from this, from 0 to num minus 1, to a number between 1 and num? There is a way to do it. Think about it. Maybe pause the video. Come up with your best idea, because we'd like to get around a number between 1 and whatever the user chooses, not 0 and that number minus 1. So how do you do it? Well, you just get your random number and you add 1 to it. You see that? Because that'll make plus 1 over here. That'll make it 1 plus 1 over here. That'll make it num. That is quite nice. Okay, so just add 1 to it, and suddenly you have a random number between the user's choice and 1. Okay, so let's ask the user for a number. Enter a number, and we're going to give them back a number, make a random number between their original number. I don't know. I need to get that number first. C and num. So this is the user's choice of a number, and then x will be our random number between 1 and num. So I need to put something here, and this will create x as x as a random number between 1 and num. Okay, so how do we do it? It's not just mod num, because we still, we're only going to get values between 0 and num minus 1. We need to do this and then add 1. Okay, you don't actually need parentheses here, but just to make it clear, I'll add them. So here we go. I now have a random number between the num and 1 and num. That's the idea. Okay, so let's output that. A random number between 1 and the number that you entered is the number that we came up with. And maybe like a period and a new line, because why not? All right, so drumroll please, what is our random number between, I don't know, 1 and 42? Yeah, 1 and 42. Oh, we picked 20. All right, let's see what the next random number between 1 and 42 is. Oh, it's 20. That's possible. All right, next random number between 1 and 42. Oh, and these characters are still the same. Something's wrong. This is not very random right now. And the issue is that random, it's called a pseudo-random number generator. So it's kind of fake, and we need to make it less fake. So rand needs to be what's called seeded, so that it makes a new random number each time. Okay, so let's go to the documentation page to learn about this. It's in C_stdlib, the C standard library. Let's find it. So here's rand, and here's srand. And if we click on rand, it'll tell you how to do cool stuff, and it'll show us using srand. So we want to seed the random number to an initial value that is nice and random and changes every time we run the program. A nice number that changes every time we run the program is our current time. So we'll just start our random number generator with our current time, and that'll make it always give us a random sequence each time. So it's never going to be the same one ever again. Okay? So yeah, just take my word for it. We're going to use the time, and this is how you use the time. You include ctime, and then you say time null or time 0. Just memorize that for now, unfortunately. That is how it works. As you say time, and if you give it 0 here, it gives you back the number of like seconds since midnight on January 1st, 1970, because that's how computers store time these days. Okay, so with that, let's use srand. And what you give srand is just some large number that you want to start your random number generator at. And that's what it will use to produce its randomness. Okay, so we're going to give it a number, and that will seed the random number generator. Okay, that's what srand does. Let's do it. Srand includes ctime for time. And so the first thing we're going to do is seed the random number generator. And then, so we'll say srand time 0. That's with the current time. With the current number of seconds since January 1st, 1970 at midnight. For no good reason, that's what we chose in the computer science world. And so with this one line, it'll be a different random number each time. And so this is very useful if you're like programming a game, because you want to have a new player, a new playable thing each time. You need it to be different. And it looks like we got a capital M and then 2 unprintable characters. All right, how about 42 again? Yeah, now we got 4. How about, oh, QUI, 42 again. Remember, between 1 and 42 is 9. Just to confirm that we're doing it right. Oh, we got a question mark this time, some punctuation coming into play. If I do 2, it should always be between 1 and 2. And if I try enough times, we'll convince ourselves that it's always going to work. Well, it looks like it's never giving us 2. There it goes. So it is random, it does work, and it does change each time. Okay. That's a lot. That was fun, though. Finally, let's talk about string operations, because strings are cool. And so whenever you want to do string stuff, you include string, the string header, and this is what it gives you. Now we can look up what it does. I think it's, is it in other? Yeah, there it is. So it's in other. And here is your string library. Here's all the stuff you can do to strings, convert between stuff. If you click on string, these are all the operations you can do on a string. Okay? So, just like you can get a particular character out of a string with .at, you can do many more things. All right, so let me just go through the list. If you have a string s, I don't know, here's my s. Remember that, like, if I say this, if I say string s equals hi or something, remember that it's really a bunch of characters, first h, then I, and these are in indices, not 0 and 2, but 0 and 1, okay? And I can ask, like, how big is this string? I can say s.size, parenthesis, parenthesis, and that'll give me back 2 for this case, because there's 2 characters in my string s. Okay, so that is the first thing that I want to show you. And it's a bit different. These functions, they're still functions, but they work in a bit of a different way on strings, because you have to use this dot. It's very odd. These are called methods instead of functions, okay? So it still all works. So size gives you the length of a string. and let me show you it working. So here we go. So yeah, size. I'll make a string, and then I can output its dot size. Okay, so it's a bit different because you have to say s dot instead of just size s, things like that. Strings.cbp, I'll include string. I don't need any more of these. And this is all well and good. So let me make a string, or let's ask the user for one, because why not? Enter a word. With cin, you can only get a single word at a time. String s, cin, s. So now I have my word sitting in s. Let us output the size of it, s.size. So enter a word, I don't know, hi mom. That's 5. It's 5 characters long. Okay, so this is called a method. Is a method call rather than a function call. We'll talk about what this means later, but the idea is that it acts on s somehow. The dot gives it away, and it acts on s. So it's as if we were really calling, like, I don't know, size of s, but we just do it in a different way. Let me put this in quotes for fun, and let's keep trucking. So that's string size. It will come in handy one day. String plus is also very fun. So here's s1, here's s2. It's quite easy to add 2 strings to themselves. So if s1 was hi, s2 was mom, s1 plus s2 gives back hi mom. If I could spell. That's also quite useful. So maybe I can put an exclamation point, or 3 exclamation points at the end of my s. So like string s2 equals s plus 3 exclamation points. Okay? Adding strings works like just adds characters, appends characters. And it creates a brand new string for you to use. So you can say cout, cout s2, and a new line. So I do this, run the program, hi mom, it'll add those 3 exclamation points. That's quite nice. And you can read more about all of these things on the documentation page, and I encourage you to. So yeah, it's the operator, the plus operator. You can append to an existing string, in fact. So yeah, all these work. Operator plus is the one we just used. We added 2 strings together. Let's see what else. Find finds the index of the first occurrence of a character inside a string. So if I wanted to find the, I don't know, the H character, remember that characters have single quotes, the H character in my string s, that would give me back index 0 because it appears. And if I gave it a character that didn't appear, like, I don't know, C or something, it would give me back -1 because that's an index that can never exist. It tells you that it's not there. All right, let's do something like this. Cout s dot find I or something. Index of I. Oh, oops. The character I. It thought that there was a variable called I when I said that. That was my mistake. Recompile, rerun. So, hi mom, the index of I in this string is 1, because that's where the I lives. Okay, so that's find. Replace is nice. Dun dun dun. S dot replace. You give it 3 things: start, and then len, and then you give it a new string, s2, let's say. So what replace does, it's quite complicated. It replaces len characters from s, starting at index start, and replaces those characters with s2. Okay, that's the idea. So it's best explained with an example, I think. I don't need to code this up, but let's pretend that we said here, like, let us replace s dot replace, I don't know, starting at index 1, replace one character with, I don't know, aha. That will turn s into, take a second to think about this, turns x into, well, it was, all right, take hi, start replacing at index 1, replace one character, so we got rid of this one, replace one character with all this, so it becomes haha. Okay, so that's replace, and your book's going to explain these all over again, so I'm just giving you a taste of all these. Substring, finally, is start len, and what substr does, gets len characters from s starting at index start. So if I had, like, I don't know, if s equals my name, if I wanted the ton part, I would say s dot substr starting at index 0, 1, 2, 3, please take 3 characters. Okay, so that's how you do it. And that would give me the ton. So lots of cool stuff you can do on strings. Let me show you that last one in action. Cout s3.substr, what was it? 3, starting at index 3, take 3 characters, and then print out that new string and give us a new line after it. So I don't know. We get the ton back. Beautiful. Okay, so those are many a string thing, and hopefully you will get some use out of these. Just a bunch of little libraries with fun things that you can use to make your life easier as a programmer. So these are libraries, okay? You're checking out, not books, but little mini programs, okay? I have included some exercises, as I want to do in this class, that are for you, and you can yell at me if you have any questions about them. I'm not going to give you the answers unless you ask, but like, think about these, because they're very helpful in like solidifying all the things that I've been teaching. I want you to explain the difference between 1, 2, 3 and 1, 2, 3. So this is something else in C++. What's the difference? Maybe think about this. This one I'll do with you, and then the other two will be just for you. So 1, 2, 3, that is a number. Technically an int, but you can squish it into a double if you wanted to. So it's a number, and this, between quotes, is a string. Very, very different. On numbers, you can do the following. You can add them, subtract, multiply, divide, etc. Use pow, use square root, all these new things. But on strings are just a bunch of characters. You can add a string, but it's very different than the numbers add, okay? Those are not the same. You can get the size, you can get substr, but you can't do number stuff on a string, just like you can't do string stuff on a number. You can convert, there are ways to do that, but that is initially not the same. Okay, so the types tell you what you can and cannot do. That is the idea, and different functions get implemented that work on different types of things. Okay, so keep types in the back of your head and you will do very well in this class. And then for your last two, I encourage you to write a program that calculates this, just to prove that you've got everything under your belt, all these little math libraries. Like set like x to 3, a variable called x, and then print out whatever this is, and double check yourself with the calculator. And then finally, try to write a program that gets a random number between 10 and 100. How would you do that? Convert it to a string and get the second digit. Okay? How would you, we know how to go from like 1 to a certain number randomly. How do you go from 10 to a certain number randomly? Think about that. And then finally, as a nice little hint, there's a way to convert a number to a string, and it's using this to_string function, which takes something, string, and then you give it the number that you want to convert. And that lives in the string library, and you can look at that. Okay, so give that a try if you're feeling like it. And that is all I have for you today. So that's the end of these slides. We'll start with some new ones next lecture. But we came far. We learned about numbers, and then we learned about all these different libraries that work on numbers, yes, but also other things as well. Okay, numbers and strings. And the list goes on, and I encourage you to look at all these little libraries, because you don't want to have to reinvent the wheel when you're solving your programming problems. You want to use stuff that's already been done and made for you. Okay, so with that, that's the end of this lecture, and I will see you in the next one.